to bridge multiple wires together. And just like sometimes we give a name called the repeater, okay, try to extend the length of the wire so that the two holes can be connected directly together. Okay, so this device is also called a repeater. And in the old days, we used a device called the hub. Okay, so the hub basically is sometimes is called a physical layer repeater. Okay, what it wants to do is try to extend the length of the wire. Okay, by connecting these two devices together. So the hub will sit in here. Now what it wants to do is, if it receives the frame from one device, from one host, it will forward the frame to another host or to another hub. Okay, so this is the device being used in the old days to connect different machines together. Okay, now it is done in the sense that the operation is very simple. So the idea is, whenever there's a bit coming from one link, okay, this bit will be forwarded to all the other links at the same rate. Okay, so when there's one bit coming, this one bit will be forwarded to all the other hosts. Okay, so you will broadcast to all the other hosts. Okay, now all nodes connected to the hub can collide with one another. So in this case, they rely on the host itself to detect if there's any collision. Okay, so there's no CSMA CD protocol implemented in the hub. Okay, and just rely on the host network card to detect a collision using the CSMA/CD protocol. And there's also no frame buffering, because one bit coming, and this bit will be broadcast to all the other hosts. Okay. Now the thing is, if it does that, okay, so one host may receive some frame which does not belong to itself. Okay, so it will check the destination MAC address to see if it matches the corresponding Ethernet its network card address. If they match, then in this case it will forward to the upper layer. Okay, but in any case, the bit will be forwarded to all the other hosts. Okay, will be broadcast to all the other hosts, and just let the host to check if it should take the frame by checking the destination MAC address. Now this type of hub device is being used in the old days. Okay, so they just connect these devices together, the hosts together. Now there's some limitations. Now first of all, this is insecure. Why is insecure? Because the bit will be forwarded to all the other hosts. Okay, even though the bit or this frame does not belong to the machine. So if the machine wants to capture these frames, okay, it can actually capture the frames, okay, even though the frames does not belong to it. So it is possible to find out the communication pattern between other machines. Okay, how do we do that? Actually, this is something based on what we call the promiscuous mode. Promiscuous means to take everything. Okay, so the idea is PROMISCUOUS, okay, promiscuous. So the idea is, if the network card enable the promiscuous mode, okay, it can capture all the packets, okay, even though the destination MAC address does not belong to itself. In fact, this is also the mode being used in the Wireshark. So when you use the Wireshark to capture packets, actually the Wireshark will first enable the card to be turned into promiscuous mode, so as to capture all the packets even though the destination MAC address does not belong to the network card itself. Okay, so this is insecure, because if you capture every packet which does not belong to you, you will be able to listen to all the other communications, which is not good. Now second, this is slow forwarding. Why is slow forwarding? Because when this frame send to here, it will broadcast to all the other hosts. At this moment, these other hosts cannot send the frame, because otherwise there will be collisions. So the bandwidth will be somehow reduced by half, because each time when the frame send in and split to other hosts, they cannot send anything. Okay, so they have to wait until the frame is received before they can send the frame out. So it is slow forwarding because it occupies a lot of bandwidth, because they just broadcast the frames to all the other hosts connected to this hub. So the idea is, can we improve the implementation of hub? Okay, so this is what we are using today. This is called a switch. Switch is a link layer device. Okay, so the idea is to connect the devices together in the local area network. Okay, so this is a link layer device. Okay, this is different from the routers. Okay, router is a network layer device which has the functionalities to perform routing algorithms. Switch doesn't have this functionality. Okay, it's just a simple device. Okay, for link layer. Okay, now how does it work? Why it is better than hub? Okay, so basically the idea is like this. Okay, first of all, it will first store and forward the Ethernet frames. Okay, and instead of just forward the bit blindly, okay, to all the other hosts, it will first store the Ethernet frame. Okay, and look at the destination frame's MAC address, selectively forward the frame to one or outgoing links, more outgoing links, based on the MAC address. Okay, and also it will use the CSMA CD to try to send the segment. Okay, if there's a collision, it will wait and resend again. Okay, so this is the idea. If the destination MAC address is one single network card address, it will send to one outgoing link. If the destination MAC address is a broadcast address, it will send to multiple outgoing links. Okay, but the thing is, the switch device will first look at the destination MAC address and decide how to send the frame to the right position. Okay, so this is the key idea in the switch, and this is transparent in the sense that the host does not need to configure there's a presence of the switch. Okay, so this is what we call the plug and play. So all you need to do is just to plug the host into the switch, and the switch will be, and then you can directly connect it. Okay, so you don't need to worry about how to configure the switch, because it's just a plug and play. Okay, and the switch can do some self-learning to identify which MAC address will be associated with each interface. Okay, so let me give you an example to understand what that means. Okay, now actually one key thing about the switch is it will allow multiple simultaneous transmissions. So what that means is that, let's say A wants to send a frame to A prime. Okay, now traditionally in the hub, okay, and this is the only connection that you can make. Okay, now if B wants to send the frames to B prime, the hub cannot allow that, because when A sends a frame to A prime, the hub will broadcast this frame to all the other hosts. However, the switch will allow simultaneous transmission, so A can send the frame to A prime, B can send the frame to B prime without collision. So this is not possible in a hub. Okay, so the idea is the host will be connected to the switch. Okay, the switch will store the frame first and look at the MAC address. Okay, and decide how to send to the destination. Okay, and also this is full duplex. Full duplex in the sense that when A wants to send the frame to A prime can also send the frame back to A. This is what we call the full duplex. Okay, they can send the frames to each other simultaneously. In a hub, this is a half duplex. What that means is only one direction can send the frame. Okay, so full duplex basically means that you can send the frames to each other simultaneously. Okay, and each link will has its own collision domain. So this is the improvement. Okay, how to make sure that they can send the data directly. Okay, and they use the switch to allow the simultaneous transmission. So when you buy a 1 gigabit switch, okay, so what does that really mean? Okay, when you buy a 1 gigabit switch, okay, you have 6 ports in here. So usually it will refer to 6 times 1 gigabit speed. What that means is the frame can send the data through another switch in 1 gigabit, and the other link can also send the data to another host in 1 gigabit. Okay, so when you buy a 1 gigabit switch, basically the aggregate speed will be multiplied by the number of ports available. So in here, there will be 6 ports, okay, available to connect all the hosts together. Now the thing is, let's say if A wants to send the data to A prime, okay, so switch needs to know that, hey, this should be going to interface 4, and B prime should be going to port 5. Now the question is, how does the switch know this information? So the idea is, basically in the switch, okay, there will be a switch table maintained inside, okay, to map the corresponding MAC address and the interface, okay, or the port, okay, to reach the particular host, okay. So for example, there will be a MAC address of A prime associated with the port number 4. Pretty much like a routing table, except that the difference is it doesn't run a routing algorithm, okay. So the idea is based on something what we call the self-learning. Now the question is, how exactly the entries are being created or maintained in the switch table, okay. So the idea is to use a concept called the self-learning, okay. Now first thing is, when the switch learns that which host, so how does it learn which host should be associated with each interface? So the idea is very simple. You just receive a frame, okay. For example, when this switch receive a frame from A prime, from A, okay, it will know that the MAC address will be associated with the interface 1, okay. So whenever the switch receive the frame from A, okay, it will know that, hey, the MAC address of A will be associated with the interface 1. And there will be a TTL to specify how long this entry should be stored in the switching table. Now, this is the algorithm that it looks like, okay. So basically is to record the data, okay, based on the incoming frames, okay. So if there's an entry, okay, now basically this is how the algorithm to set the routing table. So let's work through this. So first, it will try to record the link that is associated with the sending host, okay. So if there's an entry found in the destination, okay, so the destination, basically it will forward the frame to the interface that, so basically if I receive a frame for A, okay, then if there's a frame, this is destined to the host A, okay, it will send to interface 1, okay. Now if there's no entry found for the destination, okay, at the beginning I don't know where A prime will be. So this will work like a hub, okay, just forward the frame to all the other hosts. Now however, if the other host send, so A prime will receive the frame and return another packet. So based on the incoming frame, okay, I would look at and then I would add another entry to the table. So this is just an illustration to see how it works. So initially, A prime, the frame will be broadcast to all the other frames, okay. Now A prime knows that this is the corresponding MAC address, so it will return the frame back to A. in this case, okay, the destination, the source MAC address, which is A prime in here, will be associated with the interface. Okay. Now this time the destination A will be known. Okay, so it will use this table and directly send the packets to the frame A. Okay. And this is the concept about what we call the selective send. Okay. Now, there's some trick in here. So if the destination on the segment from which the frame arrived, okay, what it means is if the destination is just equal to the from where it is arrived, okay. So in this case, this is a normal. So basically, it would drop the frame, okay. Now, usually the destination should be on another interface from which it arrives. So it will forward the frame to the associated interface. So there's a checking in here. But the idea is basically how it looks like. So you learn from the receiving frame, okay? Again, you look at the animation again. So initially, the table is empty. So you receive a frame, okay? You know that interface 1 is associated with the MAC address A. Now, if it doesn't know where A prime will be, it will start to flood, okay? Just like a hub, okay? You send the frames to all the other hosts, okay? Now A prime should be the one that returns the frame, okay? So it gets the frame and make a reply back to A, and at this point of time, A prime and interface 4 will be added to the switch table. And now the switch knows that, hey, I know where destination A is, and this is for interface 1. So eventually it doesn't do the flooding anymore, but instead it will directly send the frame to A. Okay, so this is what we call the selective send. And B and B prime can do the same thing. Okay, so B and B prime can send the data together, while A and A prime can send the data together, and they don't interrupt with each other. So this is how it looks like. Now you can generalize this to a larger number of switches. Okay, so this is how we actually connect all the machines in different buildings. So for example, CSC department is on the first floor and also on the 9th floor. The question is, how do you have one switch to connect everything together? I mean, you have to pull a very long wire to do that. So in fact, what we do is just connect multiple switches together, okay? So this is how it looks like, okay? So you have a small network in here, and there's another small network in here, and another small network in here, and they all together will be connected with another switch. So there will be a hierarchy that connect all the hosts together, okay? All the hosts will belong to the same local area network. So what that means is, if A wants to send something, want to broadcast a packet, so it will send a broadcast packet. So BC will receive this, and also D, E, F, and G, H, I will also receive this. Okay. Now, logically, A and D can reach each other through one single link, although in fact it has to go through multiple switches. But this switch by itself is transparent to the end host. Okay. So for example, if A wants to send a frame to G, okay, how does S1 know to forward the frame to G? Okay, again, it will use the self-learning. So A, so A will send the frame to S1. Okay, S1 learned that, hey, actually, G should be in this interface. Okay, so it will selectively send the frame to S4. But initially, it will flood the frame. Okay, so that flood the frame to all the hosts. Okay. Now S4 will know that G should be associated with this interface, so it will send to this host, this switch, and this switch will learn that G is in the interface. So this is basically to generalize the self-learning to multiple switches. Okay, the idea is just identical to the single switch case. Okay, so this is the way of how to form a large local area network. The idea is to interconnect multiple switches together. Okay. Now suppose that if you want to show the switch table and packet forwarding in S1, S2, and S3 and S4, okay, so you can find out how it does. Okay, so if C want to send the frame to, let's say I, okay, so how to send and I responds to C, then you can come. So the question is how to show the switch table amongst all the switches, and you can do this at home. Okay, so this is the homework exercise. Okay. So to make it even a larger scale, so that actually how it looks like. So this is the whole subnet, okay, and there will be a router that will connect to the external network. So if you want to set the default gateway, how to set the default gateway? You will set the default gateway of this interface, okay. Now how to send the frame to this interface? Again, you send this using the ARP, okay. First you find out where the MAC address is, and you send this to the interface, and the switch will use the self-learning to specify how to forward the frame to the corresponding write interface. Okay, so this is how it looks like in the actual campus network. Okay. Now, what's the difference between a switch and a router? So we talked about router before. So actually, the main difference is the router is the network layer which implements the routing protocol, while the switch in here will be the link layer device. Okay, so the router will maintain the routing table, which is obtained by using the routing algorithms. So you will run the routing algorithms with other routers in order to get the routing table. On the other hand, the switch in here will maintain the switch table, which is obtained by the self-learning algorithm. Okay, so look at the receiving frame, look at which interface it comes from, and try to add the entry to the switch table. Again, the way of forming the routing table or the switching table are different. Okay. There's also another type of device called the bridge, which I didn't talk about in detail, but you can think of the bridge is something between layer 2 and layer 3. And sometimes we call the bridge to be layer 2.5. So it has some functions about the switch and also have some function about the router. But I won't talk about the details in here because it's getting fade out today. So we don't use bridge in here. But again, this is a device which is between layer 2 and layer 3. Now, what happens today is when you buy a Cisco router or Cisco switch, actually the device have both the switch functionality as well as the routing functionality. Okay, so you can make a router become both the router as well as the switch. Today, a lot of these devices will have both of these functionalities. So again, they are just put in one physical device. Of course, there are also some switch which doesn't have the routing functionality. Of course, they will be cheaper, and you can easily get this switch just like for $100. Okay. And there's another type of switch called the programmable switch. Okay, which means that you can hard code some mappings inside the switch or control the rate of the switch. Somehow behaves like a router, which you can do rate limiting or some other routing functionality. But again, so the difference between a router and switch sometimes is kind of ambiguous. But if you really ask the difference between these things, these are the main difference. Router is the network layer device, and switch is the link layer device. Okay. This is just what you need to know. Link layer, again, there's a lot of protocol issue which I didn't talk much about detail. But one thing which you need to know is about the ARP protocol, which is to obtain the mapping between the Ethernet address as well as the IP address. And how to connect these devices together is to use a hub, okay, which is for the old days. and using the switch which has the self-learning and how to and provide better performance than CUHK. Okay. Any questions? Now this is what you need to know for your final exam. So please make sure that you start early. And if you have any questions about assignment 3 or the exam, you can always ask. Okay? We'll stop here today. Thank you for coming. I appreciate that. switch 嘅，不過咧佢只係攞一個方力 tree， 即係好似一個 shortest path， 即係好似當佢係即係有個叫 spanning tree 嘅，佢將啲 switch 做 connect together， 之後即係你唔會即係有個 topology。佢一開始唔知嘅話，即係拎，即係如果好似層面嗰個框架或者做下踩歪，知道嗰個就由於就執翻嘅人，或者掉翻即係一開始做，即係而家就係而家好專業幾多咩？即係會成啲個係依個係冇嗰啲都有，但係就冇咁快啲地方，即係因為佢個變一炒邊度可以有個即係佢可以一個新嘅。即係而家 bridge 就好少人出嚟要做咯，因為佢做關難關。應該唔會咯，即係嗰邊藍色字直嗰隻都係啊係嘅，或者我咁主要個 temperature 就一個咧，後個3個位咧就係嗰個 gram， 另外嗰3個咧就係自己廠上自己即係佢哋係得個3個位。即係佢需要3個分，係啦，或者佢再3個係啦，冇錯。即係會講，然後要考嘅，即係 software 講，即係 burn 嘅人嘅張卡，即係佢即係自己做嘅，即係佢呢啲係拎嚟 software 講。即係拎呢樣咁咪有數嘅，考嘅嗰個就係考嘅，即係佢真係安位喺嗰張卡。有得 smooth 嘅，只不過就係個 software 咧會玩，即係你嗰個 ARP 個 software 一開頭係啦。但我用嘅 software 跟住你有 enable 翻一個 promiscuous。就算即係一 flood 明啦，即係 flood 嗰一刻做你就收到㗎啦。但係實際上 hardware 嗰個 Mac address 就唔可以講。但係就開始係再水冇要收翻。 switch.